Thank you for listening. This course was created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional podcasts, books, newsletters, and cool merchandise await. Let's get started. Mitigating bias is not about reaching a final point of perfection, but about recognizing that bias is persistent, subtle, and woven into every stage of artificial intelligence systems. Even after careful measurement, disparities remain, because the social and technical systems that produce data are themselves imperfect. This makes mitigation a matter of active intervention rather than passive observation. Fairness cannot be achieved once and then forgotten. It is an ongoing process requiring vigilance throughout the lifecycle of data, models, and applications. Thinking about bias as something that must be revisited repeatedly helps organizations avoid complacency. Just as routine maintenance keeps complex machinery safe and functional, continuous mitigation ensures that AI remains aligned with the principles of equity and responsibility. One of the earliest opportunities for bias mitigation occurs before models are trained, in the stage often called pre-processing. At this point, organizations can balance representation in their datasets by resampling to give underrepresented groups greater weight. Synthetic augmentation may also be used, creating additional data points that reflect diversity and fill in gaps. For example, in speech recognition, generating synthetic voices from different accents can strengthen fairness across linguistic groups. Removing sensitive attributes, such as gender or race, is sometimes applied, though this must be done carefully to avoid erasing information that could be used for fairness checks. Pre-processing methods remind us that responsibility starts not with algorithms, but with the data they consume. Reweighting strategies provide another way to address imbalance. Instead of changing the raw data, reweighting assigns different levels of importance to data points during training. This helps compensate for minority groups that are present but underrepresented, ensuring that their influence on the model's learning process is proportionate. Adjusting objective functions in this way helps preserve utility while also nudging outcomes toward equity. Consider a credit scoring system where data about younger applicants is sparse. Reweighting their records ensures that their experiences count more heavily, balancing influence without fabricating new data. In effect, reweighting reshapes the training process to reflect fairness goals while preserving overall accuracy. In-processing approaches bring bias mitigation directly into the algorithms themselves. This involves modifying the model during training rather than before or after. Fairness constraints can be added to optimization processes, ensuring that accuracy is balanced with equity across groups. Adversarial debiasing is another technique, where models are trained alongside a secondary network that tries to predict sensitive attributes. Success comes when the main model produces outputs where those attributes are less detectable. Adjusting loss functions for parity also falls into this category, deliberately penalizing inequitable outcomes during learning. These approaches demand technical sophistication, but are powerful because they reshape how models learn from the ground up. They illustrate that fairness can be built into the DNA of an AI system rather than tacked on later. Post-processing approaches intervene after a model has already been trained. Instead of modifying data or algorithms, they focus on adjusting predictions or outputs. Calibration is one method, where thresholds are tuned so that different groups achieve more consistent performance. Relabeling or probability adjustments can also be applied, refining predictions to correct inequities without retraining the entire system. These techniques are especially valuable when models are already in use, but need immediate improvements in fairness. Imagine a hiring algorithm whose threshold for recommending candidates can be adjusted separately for different demographic groups to ensure equal opportunity. While not as transformative as pre- or in-processing, post-processing approaches provide practical pathways for rapid bias reduction. Fair representation learning represents an exciting area of research that seeks to embed fairness directly into the way data is represented within models. By training algorithms to create latent spaces mathematical abstractions of data that minimize group disparities, downstream tasks benefit automatically. For example, If text embeddings are constructed in a way that strips out gendered stereotypes, any classifier using them will inherit greater fairness by design. This proactive approach focuses less on adjusting outputs and more on shaping the underlying features themselves. While technically demanding, fair representation learning holds promise for creating more robust, equity-aligned models across a variety of domains. It reflects a growing recognition that fairness must be integrated deeply into the technical core of AI systems. Scalability presents a persistent challenge when organizations attempt to apply bias mitigation consistently across large, complex datasets. Methods that work well in small pilot studies can break down when extended to millions of records, leading to uneven results. Different teams may interpret or implement mitigation steps differently, creating inconsistencies that weaken effectiveness. Automation becomes vital in such contexts, since manual adjustments cannot keep pace with the volume of modern data. Establishing standardized practices, clear protocols that all teams follow, helps reduce fragmentation and strengthens credibility. Without such coordination, bias mitigation risks becoming patchy, leaving vulnerabilities hidden within scale. Thinking of scalability as a governance challenge as much as a technical one helps frame it as an organizational priority, not just an engineering hurdle. Organizations themselves play a central role in ensuring that mitigation happens and that it has real impact. Assigning responsibility for fairness outcomes clarifies who is accountable for monitoring and addressing bias. Providing resources, whether through dedicated teams or budget allocation, signals that fairness is not a side concern but part of the mission. Training technical teams in fairness techniques equips them with the tools needed to implement solutions effectively. Embedding accountability into governance, such as board oversight or mandatory reporting, adds legitimacy and reinforces commitment. Responsibility for mitigation, then, does not rest solely with engineers. It is shared across the organization, anchored in leadership, and distributed through culture and practice. Strong documentation practices reinforce these organizational commitments. Recording the specific mitigation methods applied at each stage creates transparency and reproducibility. Capturing the rationale for chosen approaches ensures that trade-offs are visible and can be revisited later. For regulators and auditors, this documentation provides evidence of diligence, showing that mitigation is not improvised but systematic. Versioning and changelogs make clear how strategies evolve over time, providing insight into continuous improvement. Documentation also supports internal accountability, as teams can compare results and refine practices based on shared learning. In this way, documentation transforms fairness interventions from ad hoc adjustments into a visible, auditable history of responsibility. Evaluating the effectiveness of mitigation efforts is critical, since interventions without validation risk becoming symbolic rather than impactful. Comparing outcomes before and after mitigation helps determine whether disparities have genuinely narrowed. Using fairness metrics provides objective benchmarks for validation, while tracking stakeholder satisfaction adds qualitative insight into whether changes feel meaningful. Periodic reassessment ensures that early gains are not lost over time as contexts shift. Evaluation closes the loop, turning mitigation from guesswork into evidence-driven practice. It also strengthens trust, showing stakeholders that organizations are willing to test, measure, and report the actual impact of their interventions. Without evaluation, mitigation is incomplete, since good intentions alone cannot guarantee fairer outcomes. Cross-disciplinary input enriches both the design and evaluation of mitigation strategies. Ethicists can highlight moral implications that technical fixes may overlook. Social scientists contribute expertise on systemic inequities, ensuring that interventions do not unintentionally reinforce harmful dynamics. Communities affected by AI systems provide lived perspectives, pointing out harms or benefits invisible to developers. Governance and legal teams add further alignment with regulations and societal expectations. This holistic approach ensures that technical solutions align with values, not just numbers. Bias mitigation is too complex to be left to one group alone. It demands dialogue and collaboration across disciplines and stakeholders. Such collaboration builds both legitimacy and depth, ensuring that fairness is pursued comprehensively rather than narrowly. Integrating mitigation into the lifecycle ensures that it is not treated as an afterthought. Planning for fairness early in design makes interventions more effective and less costly than late-stage adjustments. Applying mitigation at multiple points during data preparation, training, evaluation, and deployment creates layers of protection. Monitoring systems in production ensures that new risks are identified and addressed quickly. Sometimes, responsibility even requires retiring systems that cannot be corrected, acknowledging that not every technology can be made safe or fair. Lifecycle integration reflects maturity. Fairness is not an extra step, but a thread woven through the entire development and governance process. It ensures that responsibility endures throughout the life of a system, not just at launch. Ethical considerations remind us that technical fixes alone cannot resolve all fairness challenges. Tokenistic adjustments, making superficial changes without addressing root causes, risk undermining trust. Meaningful gains require interventions that actually shift outcomes for affected groups, not just improve metrics on paper. Recognizing the limitations of technical methods keeps organizations humble, aware that societal inequities extend beyond what algorithms can repair. Combining technical measures with cultural reforms and policy changes provides a fuller path to fairness. Bias mitigation must therefore be understood as part of a larger ecosystem of responsibility, one that includes human judgment, organizational values, and social dialogue. This broader perspective prevents mitigation from becoming a narrow or purely mathematical exercise. Looking forward, the field of bias mitigation is evolving quickly. Dynamic methods that adapt to changing data environments are being developed, offering more resilience against drift. Automation through machine learning promises to streamline fairness interventions, reducing the burden of manual oversight. Hybrid approaches are emerging, combining pre-in and post-processing techniques into coordinated strategies. Increasingly, regulations are integrating fairness obligations directly, requiring evidence of mitigation as part of compliance. These trends suggest that bias mitigation will become both more sophisticated and more standardized, embedded in the structures of governance as much as in technical design. Practitioners can expect the toolkit to expand, but also the scrutiny to intensify. From this discussion, several practical takeaways stand out. Bias mitigation spans multiple stages, from pre-processing to post-processing, each offering unique strengths. Trade-offs are unavoidable, requiring thoughtful design and awareness of costs in accuracy, resources, and complexity. Documentation and evaluation are not optional. They provide the evidence and accountability that make mitigation credible. Above all, fairness is not a one-time task, but a process requiring continuous oversight. Practitioners must approach mitigation as a living commitment, one that evolves alongside both technology and society. With this mindset, bias mitigation becomes sustainable, helping organizations balance innovation with equity in responsible ways. Looking ahead, the forward outlook is clear. More automated fairness tools will be integrated into everyday workflows, making bias detection and correction a routine part of AI development. Regulators will increasingly demand proof of mitigation, pushing organizations to adopt best practices consistently. Industry is likely to converge on standards, creating shared approaches that simplify compliance while raising the baseline of responsibility. Integration into AI management systems will further embed fairness into governance, aligning technical practices with organizational oversight. These trends reflect a maturation of the field, where fairness is no longer aspirational but operational. The future points toward accountability that is both deeper and more practical. In conclusion, this episode has explored the purpose and approaches of bias mitigation, highlighting pre-, in-, and post-processing techniques, representation learning, and strategies for text, vision, and generative models. We examined trade-offs, continuous evaluation, and the organizational role in sustaining fairness. Case discussions and sector examples illustrated the real-world stakes, while ethical reflections reminded us that fairness requires more than technical adjustment. The central message is that bias mitigation must be integrated across the lifecycle, supported by governance, and reinforced with accountability. Looking forward, as fairness tools mature and regulations tighten, organizations will face stronger expectations to demonstrate meaningful action. The next episode will explore explainability, examining how making AI systems understandable supports both fairness and accountability. Thanks for tuning in to Bare Metal Cyber, your trusted source for cybersecurity educational materials, news, and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.